Okay, class, we're going to go through a lot of definitions here today. So this video might be a little longer, but you can skip to the parts you need to go to if you are just reviewing. So we're going to be graphing sine curves today. Sine and cosine are both cyclical or periodic in nature, which means they repeat over and over. You can think of going around the unit circle over and over again, and the y values that you go between and the x values that you go between. And we'll talk about that down below. But first, let's just do some definitions. So a cycle is a portion of the graph from one point to the point where the graph repeats itself. Alright, so I'll show that on the diagram below, and actually what I'm going to do is I'm going to pause and write all the definitions up so that I don't have to take as much time on the video. Hold on one second. Okay, so here are all the other definitions. You can pause the screen to write them down. Basically, the period is how long it takes to complete one cycle. The amplitude is going to be the distance from the center of the graph to the top or bottom points. We call those the crest and the trough, and we call the center line the node. The phase shift is like your horizontal shift when we did transformations, and the frequency is how many complete cycles of the graph happen within 2 pi or 360 degrees. So like I said, pause the screen to write all that down. Okay, so the unit circle, real quick, I'm going to write our points down for the unit circle. The 4 quadrant angles. -1, 0, and 0, -1. So when we graph this, we graph our angle versus the sine. And remember, the sine is like our y value. So I'm going to end this graph because to go around, we start at 0, pi over 2, pi, 3 pi over 2, and then we get back to 2 pi. So that's 0. We're ending at 2 pi. Halfway in between is pi. Halfway in between that is pi over 2, and halfway in between that is 3 pi over 2. We also know that the y value starts at 0, the highest it goes is 1, and the lowest it goes is -1. I'm going to circle all the y values. So -1. Okay? So here we go. At 0, it's 0. At pi over 2, the sine is 1. At pi, it's back at 0. At 3 pi over 2, it's -1, and then back at 2 pi, it's 0. To graph these, usually you want to make them kind of like U's. I do upside down U's when you're above the center line, and then I do right side up U's when you're below it. And these keep going forever, but since we're graphing one cycle, you can just start and stop it. The period of this graph is how long does it take to complete a cycle, and it took us 2 pi. The amplitude is 1, because that is the distance from the middle to the top or bottom. So again, this is the amp, and then this is the period. Notice how a complete cycle, it has to finally start repeating itself. So from 0 to pi, you get back to 0, but notice how it doesn't then repeat and go back up. It goes down then, and then to 2 pi. Now after 2 pi, it would start repeating itself again. So that's how you know a new cycle is beginning. Okay. Now, this is where all the transformations came in from before. Remember, when you just added something to the end of a function, that was a vertical shift. And it's the same sign as what it is. So if it's positive, it's up, negative, down. So up / down. And this is also where your node line is. This tells you where your node line is, because the node line always starts at 0, so the vertical shift will move it. We call C the phase shift, which is also your horizontal shift, which we talked about up there. And remember, this is your, it's the opposite sign, opposite direction. Oh, sine, there we go. And then A, remember when we used to multiply like x squared by 2x squared, it would stretch the graph or multiply all the y values by 2. Well, this multiplies all the y values by whatever you're multiplying by, which turns the top and bottom points into that value. So this then gives you the amplitude. I want to show you that real quickly. So here's a graph of sine. Okay, and here's one curve of sine from here, 0, 0, to 2 pi 0. Okay, we graph that. If I multiply that and put a 3 in front, look what happened. The highest the graph goes now is not 1, but 3. And the lowest it goes is -3. So it changes the amplitude of the graph. Okay? So that's the amplitude. And then B is, that's going to compress it or stretch it in the horizontal direction. So what that changes is the number of cycles in one period. So this is actually going to be your frequency. Okay? So let's graph these things. And here we're going to go through a couple problems on what you need to look for and how to graph them. I always deal with the node and the amplitude first. So I know my node is at y is equal to +1. I know my crest and my trough, or the highest and lowest points, are going to be at 1 + 3 and 1 - 3, because you're moving 3 away from the amplitude. So that's at 4 and -2. So I have all the vertical pieces I need. Now I need to do the horizontal. And there's two transformations that affect the horizontal direction, the frequency and the phase shift. Now you can do them all in one inequality, which will kind of help you out. We know normally that the graph goes from 0 to 2 pi. So you just stick the guts of the problem between 0 and 2 pi, and then you solve for x. And what that does is that gives you when the period, and then it gives you the distance, or the starting and ending points. So the first step is divide everything by 4. So we get that 0 is less than or equal to x minus pi over 2, which is less than or equal to pi over 2. This is the period. Because what this is saying is the frequency is 4, that there are 4 graphs within 2 pi. So that means that if we want to know the period, or how long it takes one cycle to happen, it would just be over pi over 2. And the last step is to do the shift. So we're shifting it pi over 2 to the right, because we're adding pi over 2, which means that the graph will start at, our cycle will start at pi over 2 and end at pi. Okay? So if I graph this, I'm going to, and this won't be correct really. I mean, we'll just say this is pi over 2 and this is pi. I know that spacing doesn't look right. This then is the middle, and then we have these. So you're always going to have 4 subsections for a sine or cosine curve that represent the 4 quadrants. Okay? Now, we need to figure out the values in between here. There's 2 ways to do that. You can average these numbers and add them together, divide by 2, ignore the pi, so 1/2 plus 1 divided by 2. Or you can just figure out how much each of these intervals are. To find an interval, you take the period, because this is a period of pi over 2 right now, because if you go from pi over 2 to pi, that's pi over 2, and we want to divide it into 4 sections. So pi over 2 divided by 4 is pi over 8. So that means that each of these will be adding a pi over 8. So this is 4 pi over 8. If I add a pi over 8, I'm at 5 pi over 8. Then I'm at 6 pi over 8, 7 pi over 8, and pi. 6 pi over 8 is 3 pi over 4, 7 pi over 8, and then sure enough, 8 pi over 8 is pi. So those are the regions I'm going to be graphing between. The starting here, ending there. The node is at 1. So my node is at 1, my top of the graph is at 4, and the bottom of the graph is at -2 based on these numbers over here. I'm going to box the area I want to graph. I know I'm going through all these numbers. That's okay. I'm going to, and then I'm going to graph it. So remember, the sine curve always starts at the node line, and then it went up to the top one interval later, then back to the center line, then down at the bottom, and then finally we end it. So that is the graph of sine of all that. That is one sine curve for this problem. Okay, so that's all you have to do. So we're going to do another one. So pause it to write everything down, go back to whatever you need help with, and then we're going to do one more. Now, we have one more change. We have this. And if you guys remember what this does in transformations, if you negate the whole thing, it's a reflection over the x-axis. Alright, so what we're going to do is, we're still going to do everything the same way. The node is at y equals -2. The crest and trough start at -2 and go up and down 4. Ignore the negative sign. That doesn't do anything with the amplitude. It's just 4 is the distance. So we have -2 plus 4 and -2 minus 4, which is at 2 and -6. So that's the highest and lowest point of the graph, and here's the middle. Now I solve for the middle piece. We set in between 0 and 2 pi, just because that's normally the period of a sine curve. Just so you know, if this was in degrees, we would say we were between 0 and 360. Alright, I multiply by pi over 5, or 5 over pi, because I want to get rid of the pi over 5. So I get 0, theta minus 3. 5 times 2 is 10, and the pi's cancel, so it's just 10 radians. Alright, and this is also, again, the period. So that means that the graph will cover, or will continue over a period of 10 radians. Okay? And then you do the shift, add 3 to everything. And notice again from 3 to 13, the period is still 10. It just tells you where to now start and stop the graph. Alright, and then the interval is the period over 4, which is equal to 2.5. So now I can graph this. I'm starting at 3. I'm ending at 13. -2, 3, 4, 5, 6, 1, 2. So we have 2, -2, and -6 are the values I care about. We have the center line, or sorry, I shouldn't say the center line, the middle, and then we get all our intervals. So the interval is 2.5. So you add 2.5 to 3, and we get 5.5. We get 8. We get 10.5. And then if you add 2.5, you should get 13, which we do. Let's graph this. I'm going to box the area that I care about. Here's the middle of the graph. Again, we start at the node line for sine. Now here is the only change for this problem. Everything I've done up to this point is exactly the same. However, this says we reflect the sine curve over the x-axis. Well, technically we're actually reflecting it over the node line because we did a vertical shift. We should have done that first. So what happens to the graph is, instead of going up first, it goes down first. So a negative sign goes down first once starting with starting at the node line. Okay? So that is one cycle of this sine curve. Only difference was it went down first. So, alright, and then the last thing is I'm going to give you this, and I just want to talk through some things, some easy ones. This is always the vertical displacement, which is up 7. Make sure you tell me directions. It's also where the node line is, so this is y equals 7. The amplitude is just 2. We do not worry about the negative sign. That deals with just graphing. Because you go up 2 from this node line, the max can get all the way up to 9. We could also go down 2 from that 7, so the minimum value is going to be 5. The frequency is just given as 3. The phase shift, since it's a plus 30, it's 30 degrees to the left, because remember it's the opposite of what you would think. The period of one cycle. Remember, to get the period, you just divide. You can put this whole thing into your inequality, but really it's just the period, the normal period, which is 360, divided by 3. So the period here before the phase shift is 120 degrees. Okay? Or you can just, like I said, take the period and divide it, or take 2 pi or 360 and divide it by the frequency. Okay. So anyway, that is the answer. Those are the answers. So we will do cosine tomorrow, which doesn't change much.